Hello, hello. How's everyone doing? Good. It's the final panel of day one. Thank you for sticking around. Just quick poll. How many people are familiar with zk technology? Nice, and some excitement, some excited people here. Great to hear. Awesome. So today, our panel is focused on just talking about a little bit about zk's history, how far it's come, where we are today, the current landscape, and then diving into some use cases, like what can this technology really be used for, talking about some applications. So with that, I want us to do quick introductions, just like who you are, a little bit about your project, and then we can dive into the panel. Maybe Jordi, you want to start first?
Yeah, well, I'm Jordi Baylina. Currently, I'm the technical lead at Polygon zkEVM. But before building rollups, I built Circom and Snark.js, which are an important tooling for building zk circuits.
Hey everyone, excited to be in Korea. My name is Anthony DiPrinzio. I work on ecosystem growth at Aleo. And Aleo is building a layer 1 blockchain that's enabling developers to build private and programmable applications on the web. We do that through our zk DSL and compiler called Leo, and we have a whole stack enabling developers to do that, including a zkEVM and an operating system.
Hi everyone, my name is Brian McKenna. I'm head of product at Mina. Mina is a layer 1 blockchain that implements zk natively at the base layer for a few purposes, but one is to make a succinct, lightweight blockchain, and the other is zero-knowledge applications through our library, Snarky.js.
I'm Fede. I'm the founder of LambdaClass. We actually worked a little bit with Mina, with zkSync, Starknet, and many other blockchains from the space.
Awesome. And my name is Vora. I work at a project called Risczero. We are building a general purpose zkEVM, which is zero knowledge virtual machine. With that, I just want to talk a little bit about, are you guys familiar with the Gartner hype cycle? Show of hands? Okay, cool, no worries. It's essentially talks about the adoption curve of any new technology. And so there are different phases when a new technology gets to market. The first phase is the innovation phase, where there are technical breakthroughs, new ideas are coming to fruition. That's called the innovation trigger. The second phase is essentially peak of inflated expectations, where there's a lot of interest in this technology. There's a lot of people talking about it. There's a lot of ideas, blogs, social influence around this technology that's been created, and the technology kind of becomes a word that people recognize, but don't really fully understand it. And then after that phase is kind of the trough of disillusionment, which is, there's so much excitement, but the products take a lot longer time to come to market because these technologies are hard. They take a long time to just be, production ready. And so expectations are here, but the technology and the products are not meeting those expectations. So there's a little bit of a downfall. And then you reach a stage where the second or third iteration of these products are coming to market, and you again start seeing kind of adoption go up. So with that context, that's usually what technologies follow. I'm curious what the panelists think where zk falls in this Gartner hype cycle.
I would say probably at the point where the technology is available. It's really available. It's not about talks. It's about the tooling is developed. It's still early stages, but the technology is available. Right now, there are many running in production applications. Here we have a good example of those. So the technology is available. But said that, we are in the early days. That happens. So probably, I don't know, maybe in this curve, in the beginning of the ramp.
Yeah, according to Gartner, we are at the peak of inflated expectations, right? It's like this technology, we are talking a lot about it, but in reality, it's still a little difficult to use. So I guess anyone else agrees on where we are?
If we're to take a metric about zk developers that exist, I think a few years ago, I think somebody said that you could find all the ZK developers in the world, put them in a room, and feed them off like 4 pizzas or something like this. I don't know how long ago that was, but it's definitely on the way up, like accelerating fast, but it's still quite low. And like with better tooling and better libraries and better accessibility for programming this type of stuff, it should continue.
Yeah, I'm curious, Jordi, you've been in the ZK space for a really long time. Can you give us a little bit of history, how far we've come, the technological breakthroughs that we've achieved, and where we are today?
Yeah, well, the zk zero-knowledge technology was invented in the 80s. The beginning was, I would say, very much a theoretical, mathematical thing, but the stage useless, like many of these technologies at the beginning. But there was, I would say, from 2005, 2008, that then this concept of succinct zero knowledge starts to come up. I would say here that there was, at least from the blockchain perspective, for me there was a very important project in the space, that's Zcash. Zcash was the first blockchain that actually uses zero knowledge protocol. It was not even Groth 16, it was like something previous to Groth 16, they switched to Groth 16 later on. And I would say that I'm sure that all of us, we drink a lot about the work that was done in the early stages in the ZK. It was a lot of researchers, and from there was, I would say, an important blog post that was a huge revolution for the space. It was a Vitalik blog post talking about how to scale blockchains with zero knowledge. This thing is what, well, I mean, zero knowledge was known very much for privacy, and privacy don't have a good sell, and was difficult to get some traction. But at the moment that the people realize that, okay, this technology can be used also for scaling, and then is, I would say, with everything accelerate a lot in the research, and especially in the post-research. I mean, it's all this in building the tooling, in understanding, in learning. This was 2016, 2017, where all this kind of revolution happens. And since there, many new protocols, many new toolings, many new applications, and yeah, we are in this growing. But more, I mean, this is a summary. I'm sure you can complete with some other items, but that's...
No, that's a great summary. Essentially, this technology started with like cryptographers, math nerds, people who were deep in the weed. It was really academic initially in the 80s and 90s. A lot of research and papers were written on it. And then in the last, I would say, like 5-6 years, we are seeing implementation of this technology come to fruition, especially because in the blockchain space, there's a lot of excitement around this technology, and there's a lot of investment that's going into this technology to come, to bring it to market. So that's a really, but I think, Anthony, you wanted to add something?
Oh yeah, I was just going to say, if you think about the entire history of like the space, right? There's kind of these different inflection points. First, you had people trying to create digital money, like DigiCash, Hashcash, all these different concepts. Then you move on to Bitcoin. The real innovation was Bitcoin was the cryptographic like incentives that they came up with, right? How do you incentivize like these decentralized architectures? Then you have, 2015, 2016 era folks like Vitalik and others that said, how can we expand upon that by putting like an on-chain like virtual machine, right? So then you get the EVM and all these other different kinds of L1s coming out. And now the next revolution is taking like zero knowledge and all the innovations from there and kind of compiling on top of all the innovations that people have built from the past. And for example, that's exactly like what we're trying to do at Aleo. Like Zcash was a huge inspiration for us, and like without the work that they had done, we wouldn't be where we are today. So I think all of these things kind of compound onto each other to get us to that next level.
Yeah, so what I'm hearing is there are two kind of big buckets for ZK use cases. One, you mentioned, Jordi, is scalability, using it for scaling blockchains, and the other, privacy. Can we double down on those two use cases?
Yeah, I was going to mention that I think Zcash was the most important use case that accelerated zero-knowledge proof, especially on the privacy side. I completely agree with Jordi and Anthony. On the scaling part, I think that Eleven doesn't work on the ETH stack with Layer. They got a grant from the Ethereum Foundation, and they showed that you could scale blockchains using stacks or a proving system. And I think nowadays, most of the focus is on scaling. Long term, I do think that we should go back also to add privacy. I think privacy is important. I'm not working on that camp right now, but I completely agree with Anthony. Like, I think on the long term, we should also focus on the two things at the same time, not only on the second one.
Yeah, can we talk about some applications on both fronts, both on scalability and privacy? Like, can we make it more real for the audience?
Yeah, I can start. So one use case that I think is really interesting, and a lot of folks in Korea have been interested in just by talking with people, is applying zero knowledge to gaming, for example. And some people might ask, what does that even mean? How does that make sense? If we're looking at it from a privacy perspective, the way you can think about it is, well, the first thing you have to say is, do I want to decentralize a game? That's the first thing you need to answer, right? And I've debated with people about that, but assuming that you want to create a decentralized game, once you start trying to build out an imperfect information game, right? So a game where there's some hidden state, which is basically most games that aren't like chess or Go, or maybe like board games where you already see the full state. You need some way to maintain privacy. And there's different methods to do that, right? Like zk is not the only option, but I personally think it's one of the better options currently. Maybe that could change in the future, we'll see. But some of the other ways you could do that is through like fully homomorphic encryption. You could try to do that through like commit and reveal schemes. You could try to do that through like trusted execution environments, right? But they all have different trade-offs that you have to assess. And so on the gaming side, for people that want to create these decentralized games, zk is a really great tool to enable imperfect information. And I guess I'll just give a very easy example. Think like a card game like poker, right? Everybody has to reveal their hands at the end of a round to see who won, right? And how do you do that? Well, you place them out, everybody sees, and then we pick the winner. But imagine if we could prove who the winner was, but nobody actually had to reveal their hand, right? That changes the entire mental state of how you would play poker, because it's like, was Anthony bluffing when he won that round? Like, did he have a royal flush? What was his hand, right? And that gives you less information about what's left in the deck. So not only, does it enable those imperfect information games, but it can change the entire dynamics of it too, depending on how you apply it. So I think that's one cool application.
Yeah, I have two comments on that. On the privacy side of things, I think also casinos are very important. During the pandemic, there were some lawsuits related to influencers using web pages that they created to create a casino, and they lied to their viewers. So with privacy tools on smart contracts that support privacy, you could create actually casinos where you could show that you need some randomness from the outside, but you can show that the casino is not lying to you and it's not showing the hands that you're playing. On the scaling part, I have a very concrete use case in the next few weeks, actually in 2 weeks more or less. Starknet will have at least 100 TPS, so it's one of the first L2s that will be scaling very fastly Ethereum. The last use case I wanted to mention on the scale, well, I don't know if it's scaling actually. Yes, it is. So it's zkEVM or validity proofs with ML. Yeah, you can show that you inferred something and the inference wasn't lied or you didn't cheat. With ChatGPT, I think there's going to be a lot of bias and people trying to hack the system on adding, changing the output and trying to show, this is not biased, and it will be biased. So with these tools, you will be able to show that the system is doing what it needs to do.
I can add one that's fresh in my mind. Yesterday, I saw a demo from a Korean development team who implemented a private voting stack on Mina. So the problem is that the voting is centralized, vote counting is centralized. The votes are known to the vote counter, I guess. So this app straight from KakaoTalk, where the vote took place, in zero knowledge, executed a vote privately, so maintaining the privacy of the user, maintaining the privacy of the way they voted, but verifiably did the vote count and output the results. So that was kind of cool for things like public polls or surveys, or even applied to crypto, like DAO voting and things like this. So yeah, that was a really nice real life use case.
Love that. And then identity is a big one, Jordi. I want to, hear from you how zk can be used in the identity space.
Yeah, definitively. The way to think about identity, or if you want self-sovereign identity, I mean, identity that you create yourself. But so imagine that the identity, the way that I see it, we have users, which is public-private key, way to see it easy. We have claims or attestations, so you are saying something about something else. So this, we have a database of claims. That's a shared database. So everybody holds like part of this database, maybe the claims that are related to you or the claims that you are doing to another person. And the idea is you should be able to prove a query on this database. So you want to prove, not to give it the exact, you don't want to reveal the exact data, but you want to make a query to this database that you are holding, and you want to prove that this query is correct or not. Okay. With that, you can use zero knowledge. This allows you to prove things without having to reveal that information. I mean, you can prove that you are an engineer without having to show in which school you did that, or you can prove that you are 18 years old without having to prove at exactly what age, or you can prove that you have enough conditions. You have enough conditions to get an insurance without revealing all the medical information, or even more. You can prove that you pay your taxes without revealing how much taxes you pay it. Okay, and this, for example, with Zcash, things that, I mean, these are more futuristic, but these are things that you can really do. At the end, the zk solve in the right way one thing that until now is a balance. In the world, we have a kind of two forces. That is, in one side, we have like the security. We want to fight against terrorism. We want to fight against bad things, okay? And this goes against with the privacy of the private individuals and the right to be private in there. And we have always this tension between the two things. I mean, it's like governments is trying to get more information, okay, be less private, and the other side is, okay, we have this right of being privacy and to getting the privacy, but this sometimes goes against having some security in there. The zero knowledge technology allows you to have both things without having to sacrifice part of that. I mean, you can prove that you are doing the things, that you are passing an AML, that you are passing the KYC, but without having to reveal that information. And this is very, very, very important. This is a revolution for the humans. I would expect, for example, from the privacy laws, like in Europe we have the GDPR, but I mean, there are other rules like that. I'm sure that at some point they will enforce to use zero knowledge to guarantee the privacy of the individuals at the same time that they guarantee the security of the society itself.
Yeah, I think that's a really important point, especially when we're talking about like using zk for privacy applications. Like the regulatory landscape is definitely going to be something that needs to be considered. And that's something like at Aleo we're constantly thinking about and how we grapple with that. And more broadly speaking, I think a good way to do that is like enabling some kind of system that's maybe private by default. Like that's something we're trying to work through, where basically if you deploy some program, right, you as an application developer have the option to decide, okay, what's private, what's public, based on whatever those regulations are going to be. Or you can also make it so that as an end user, maybe you want to selectively reveal certain details about whatever zero knowledge proof you're presenting, whether it's for your identity or something else. And I like to bring this up because when people hear zk and privacy, they always think like dark, evil, like money laundering, like all these bad things, but really it's the opposite. It's actually being more enabling and actually giving people more security over their data and information, right? Like think about, outside actors like other countries that might be trying to like harvest data of like citizens, right? Like you can use zk to prevent that, but still allow like the local government to have some level of access that's necessary. Maybe not overkill, but at least something. And I think that's a really cool paradigm to explore with zk.
Look, let me put an example on that. I think it's very clear. So when I'm going to a hotel, in general, a hotel will ask for my ID. Okay? And in a lot of times we'll do a copy of my ID. Okay? And this is they are doing that probably because there is some rule. Maybe the police is asking them to do that or there's some rules in there, okay? But what happened with the information that's managing this hotel? I mean, how I know if they are taking this idea and they're going to do a false idea, or they are going to sell this information to somebody else, and so on. So I mean, I need to trust the hotel itself. So these systems allows you to give the police the right way. That I mean, that if there is somebody that's wrong, or at some point there is a way to find that person, because you are proving whatever, that this information maybe is encrypted with some law enforcement key or whatever, but you don't need to reveal to the hotel itself that I am there. And this is an advance for society, so this is important. So this is not, so it's not that with privacy, we are defending privacy and we are giving up the security. It's the opposite. We keep security, we even increase the security, and at the same time, we guarantee the privacy of the individuals.
That's very powerful. And I think, to your point, if you're giving all of that information to one central entity, those become honeypots for attacks and for security hacks, and you're giving up all of that information.
How many leaks happen every day?
Yeah. Basically, every app on our phone is like one giant hotel, like with the same analogy, And I think we want to try and get to a place where, like, as a user, I only reveal what I'm comfortable revealing for the requirement of the application I want to use, right? It's like the minimum viable information.
Yeah, that's actually part of the reason I got into the ZK space. When I was a sophomore in college, I filed my taxes for the first time because I had a real job. And I went to apply for an apartment, and they were like, it was on Zillow actually, and they have on the website a way to do like KYC AML and verify your identity, and I kept failing. I was answering all the questions correctly. And then later I found out that there was a massive data breach with like TransUnion, which is one of the three. It's like Equifax, TransUnion, and Experian, one of the three credit bureaus in the US. I had to file with them when I filed my taxes. I didn't have a choice. And literally my identity was corrupted. And I mean, that was kind of like the waking point for me.
Yeah, it was real for me when I bought a house in the US, and the amount of information, like private financial information that I had to share. Like my banker literally knows every single detail about me, which is so uncomfortable. And to your point, I think we can reveal selectively certain information, or we can meet conditional requirements without having to give all of this data. Were you going to add something?
Yeah, and I was going to say as well that like institutions and like corporations and things like this will be more comfortable like using decentralized architecture when they have privacy themselves, right? Because they have their own business logic. They have their own financial information. And, I mean, if it's a small-time single-person user, they might not care that much. But the only way for, like, institutions to actually use blockchain is that there's some degree of privacy there.
I wanted to add two things regarding use cases. I think that healthcare wasn't mentioned, but it's very similar to the hotel thing, but in an even worse case, because in many countries, there's no law to block the hospital for selling the data. And also, if you go to one hospital and then you want to go to the other one, there's no like system to do that. And like literally doctors send the files via WhatsApp or things like that. On the second thing, I completely agree with Jordi and Anthony again on the security versus like, sometimes the government. And I think that's a wrong dilemma. In the 90s, we already had that, like with the crypto wars. The cryptography wars, like they're trying to ban encryption. Nowadays, we have Amazon thanks to encryption. Like you couldn't buy or you couldn't do like worldwide commerce if you couldn't send like your credit card online. So I do think that this is for common people. It's at the end, the bad players will always find a way on. It's not that if you block this, if you remove encryption or ZK or privacy, you're not helping common people. You are doing actually the opposite.
I really like the whole discussion around privacy. I also do want to spend some time talking about scalability and like scaling use cases. So maybe Jordi, if you want to talk a little bit about zkEVMs and what they enable in like the blockchain context, and we can kickstart from there.
Yeah, I mean, this has been a a very important technology for scaling, obviously, but not for the zk. I mean, not for the zero knowledge part. It's more for the succinct part, for this validity.
Can you explain
proofs.
what's succinct?
Yeah, the idea here is that you can prove a computation. So you're doing a computation, and the idea is that you can prove the computation without having to redo the computation again, and you can verify this computation much faster. This is very important because when we are in the consensus layer, I mean, if we need to agree in some computation, that means that everybody in the consensus needs to execute that consensus. If we can save that, that means somebody just create this proof. Maybe it's going to take longer than the computation, but let's say that it has a good machine there. But in the consensus layer, all the people in the network don't have to run this computation again. They don't need to verify all the transactions again. They just verify this proof in few milliseconds, and no matter how long is this computation, they can verify this in these few seconds. This is a succinct part, and this property is actually what enables the scaling blockchains. So what enables reaching a consensus in a big computation without the individuals in the consensus, without the network having to execute that consensus every time. And this is the magic thing and the nice thing of this technology. Nothing to do with privacy, but it's really important for scaling blockchains.
Yeah, I wanted to give you a concrete example of that. So most blockchains that are not Bitcoin or Ethereum, not everyone obviously, but most of them, what they did is they took Go Ethereum, one of the clients of Ethereum. They took it, they did a few modifications, they launched a new L1. And the only thing that they're doing to make the things faster is to have less nodes or to have bigger machines. So that's not really scaling. It's not like, it's just you're changing the parameters. So I think that what this enables, validity proofs or zk, however you want to call it, is that you have an asymmetry. I can prove things on very big machines, on a cluster of very big machines, and then verify that on really small machines, even in your phone, like, well, Mina, in that way, like with Kimchi, the recursive proving, like that's like the core idea. Like you could verify computations that are very long, that lasted for, I don't know, a month. That's not possible right now, but in the future it will be. And I think that the work that Polygon is doing on the L2, and we are doing with Starkware on Starknet, is showing that you can scale the L1 without changing hardware needs or without compromising decentralization. Because what you do is you prove things, and you can even add more nodes to the network to verify that computation. As I said before, in only a matter of weeks, probably in the next 2 weeks, we will have already on testnet, and afterwards on the mainnet, an L2 that is already scaling with more than 100 TPS. And
Brian, I want to hear some interoperability use cases that you were referring to earlier, that zk enable.
Yeah, so I mean, sometimes I think the technology is applied to the most urgent needs first, right? So like scaling, interoperability, and maybe then privacy. But interoperability, we've seen that, like, you know, there were some like pretty like dramatic like failures in the interoperability system over the last few years. And there are a bunch of teams now working to use zk to create a state proof of the state of like chain A, you know, serve that to chain B where it gets verified as being A, you know, A correct state, and B the latest and strongest state from the other chain. And like anybody can do this upload, and it like executes as per a smart contract. So now sometimes it's not even like, it doesn't even sound like a bridge. It sounds like some like, you know, roll-up type thing. But yeah, I'm super bullish on this type of interoperability because like as proving times get faster and like proof markets are created, there's just going to be like so many incentives to create proofs all the time. And there's probably going to be, it's probably going to like have this just web of interoperable layers for crypto that's really trustless. So it's quite exciting. And Mina's particularly good at that because we already have a succinct state proof of our chain. So yeah, we're working under a grant from the Ethereum Foundation, and we're hoping to have something in production like this year.
Yeah, especially, if you think about the future of crypto technology and you think there would be multiple chains, I think these chains need to connect and talk to each other in a trustless manner. And I think that's where zk technology can be really viable. I guess, I'm curious what's missing. This vision for zk is, really broad. This technology can be used for so many different things, from scaling, privacy, interoperability, use cases across gaming. I think what needs to happen for us to get there to like mass adoption, to applications that everyday user can use?
Speed and tooling. Like actually the other day I saw a post by, I think it was the co-founder of Mina, Brandon, on zk Security. They were saying like you should be able to read the constraints, like these systems generate mathematical constraints, and it's very difficult. Actually, they also mentioned Leo on the blog post. It's very difficult once you run the thing to debug it. Like it's like you're generating a new IESA, I think it's in English. You're creating a new architecture, so it's very difficult to go into the details of the VM, or in the case of circuits, it's very difficult to understand it. So for developers to find bugs, it's very costly in terms of time. And in terms of performance, there's every few weeks a new proving system, or supernova, hypernova, on where we don't have many more. Yeah, we don't have many more names to all the proving. Like,
all celestial bodies.
yeah, exactly. So that's good though, because there's a lot of competition, same competition between researchers and engineers to make things faster. So I think that on tooling, like, because right now many of the users, well, now with the zkEVMs also, you won't need that, or with snarky JS, but beforehand you had to like almost write the equations to prove them. That's actually how Cairo was designed and created. The developers of Sargo were like writing constraints by hand, and they created the language to not to do that. So I think that needs to improve, and it needs to be fast. When it's going to be fast, it's going to be like the internet in the 90s. Once you had internet cables around the world, then developers found a way of creating a lot of the applications we use nowadays. So when this gets fast, it's on cheap, on proving times are faster, everybody will use this in a lot of ways.
Yeah, I agree with what Federico said. Specifically, a lot of folks I've talked to, like the tooling and infrastructure is probably like one of the biggest things. One way I've tried to improve, or at Aleo and through my job that I've tried to improve that experience, is building like a static analyzer for our programming language, right? That way, people who are coming into the ecosystem who may have a difficult time like actually figuring out where those bugs exist can have some assistance there, right? So it's all about just like creating this more fluid and easy, to understand like developer experience when you're trying to engage and build these kinds of projects. So I would say that that's like a really big one I've seen.
Yeah, I cannot agree more. I can talk about my experience. I mean, when I started learning about the zk, I could summarize my time building tooling. I mean, I started building zkEVM because, I mean, it's like, I promise you that I was trying just to build real applications. I'm an engineer. I want to build things that works, okay? But then it's like you start using it and say, okay, how I do that? And then you need to learn very complex libraries. You want to do a complex thing, and there is like absolutely unreadable code. I mean, it was very difficult. So the thing is, okay, let's build a tool. And with this, I built zkEVM for the early stages. And now zkEVM is used a lot for many people, but it's a good thing. And to build the zkEVM, mainly we built two toolings. We built the PIL, it's polynomial identity language, mainly to do all the arithmetization. Arithmetization is really important for these new systems. And then we built an assembly, because we built a processor and then a kind of an assembly. But that's a tooling. I mean, it's an assembly with all the tooling that's around. So I would say that building the zkEVM has been like 95% building tooling and 5% building the zkEVM itself. So I cannot agree more.
I think we're all in agreement here. More tooling, better tooling. And I think on performance, and I think once that happens, like the amount of experimentation and innovation will grow in the application space. And I think when the EVM came out, like a lot of the things that people thought would be built didn't actually get built. It was like different things that got built. And that was because of experimentation and people really understanding the framework. And I think with these types of applications, it's slightly, well, it's a very different smart contract framework, whereas the computation is kind of pushed to the edge of the network rather than being like re-executed everywhere. So there's much more, the design space is different, and I think the types of applications, once the experimentation phase really happens, are going to be quite different as well.
I was also going to say this is probably like a very basic answer, but I think we just need like one killer product out there that's in production that's actually working. Like, I'm not an engineer, but I have the same sentiment as Jordi. Like, I feel like I'm becoming one because I also have that mindset, and I work with mostly engineers on a day-to-day basis. So it sounds very basic, but honestly, I think when people see that, then they'll be able to jump right in. Like, if you go back to 2017, like I remember when CryptoKitties was launched, right? They were like one of the first projects to do NFTs like really well, and then it sparked all these people to start, you know, creating their own versions or other kinds of NFTs. So honestly, I think that's a big part of it too, and we're getting there. It's going to take a little bit of time, but I think we're on the right path to do that.
I have seen Anthony's transformation into an engineer. Now I forget he's not an engineer.
Love to hear. We are all engineers.
Yeah, I want to mention one thing because I think it's important, and this is it's a revolution that happened in, I would say, probably in the last years. Well, I mean, it's about recursion. I mean, I think that here we have two projects that were very, very early days because you started much earlier than that. But this zk recursion. So at the moment that we dominate, I mean, we know how to do recursion, efficient, fast.
Can you explain recursion?
Recursion is mainly verifying. So it's a proof that verifies another proof. We call it recursion, but you can have a proof that verifies another proof, or even you can build a kind of a Merkle tree of proof. It's a proof that verifies two proof, but this proof verifies two more proof, and this is what allows also to scale. I mean, to create huge proofs. I mean, we are able, in the case of Mina, for example, they are able to prove a full chain. Okay, or in the case of rollup, we are not. In the case of a zk rollup, we are not verifying like block by block. We are verifying a segment of the blockchain, and because we are aggregating proofs, so we are getting many proofs and converting in a single proof. Even, for example, in the rollups, in the system of rollups, it can be a single proof that aggregates the proof of all the rollups itself. So this is and this recursion, the fact that we know how to do recursion in a fast and efficient way, because recursion in zero knowledge, from the theoretical perspective, is quite old. I mean, I think from the beginning that we know that recursion is theoretically possible, but the last years, I mean, there are different projects that has proven that recursion is definitively possible with different stages, and this is what I think. This is one of the secrets of the revolution that will take off this zero knowledge, especially in the scalability. I mean, in the zero, for example, I mean, you have this RISC-V emulator. I mean, you can, if you don't have recursion, you can prove a very small program in there. But if you want to prove a very long program, you need to aggregate these proofs and create a big proof, and then you want to compute these proofs in parallel. And this is, recursion is really important for the zk ecosystem, and this is something that we have it right now. We know how to do recursion very efficient right now, and that's why this will take off a lot of applications in this.
Yeah, definitely agree. You can now do really, really long pieces of code in a zk context because you can break it up and parallelize it and create proofs for each, but you don't have to verify each proof. What you can do is what Jordi explained, is this like roll-up concept and have a single proof that can verify a huge amount of code. Did you want to add, Brian?
Yeah, like the application then is then a roll-up, right? Because it's all recursively proving each other. I think a good way to understand recursion in the application is like a game. So, you know, player A takes a turn, proof is generated, state is update, the player B takes a turn, using the proof of the previous state and the turn, and like this goes on and on and on and on and on. And at the end, it's like you just have one proof of the whole state of the game, at you know, constant size that doesn't have to go and get like executed around the whole blockchain, right?
Yeah. Actually, one use case is related to the one you mentioned before about storage proofs. We're helping a team, for example, prove that users read something from the blockchain or wrote something to the blockchain, and you cannot like upload a proof every time something like that happens. You need to batch many people doing something, creating the proofs, and then recursively doing that with all the users. So yeah, like without recursion, I think many of these proof systems wouldn't work. Actually, for example, Starks, the proof system used by actually Risczero, us, many other teams, the proofs are very big in comparison to Starks. Like they're 1,000 times bigger, but if you recruit many proofs, you don't care because you upload one proof that has checked all the other proofs. So yeah, recursion is crucial.
Yeah, essentially, we are, like I mentioned at the beginning of the panel, we are at this like innovation trigger, peak of inflated expectation. The technology is moving really fast. There's a lot of technical breakthroughs, recursion, folding schemes coming to light. So there's a lot of research, there's a lot of work that's going behind the scene to make this technology more performant, more easy to use. And then once that technology reaches a stage of maturity, there's also tooling that's required for developers to be able to, you don't have to go behind the scenes and like learn the cryptography and understand and have to build the tooling every time you build an application. And so we'll have this like tooling layers built in. And education is a big component. I think people like right now get scared when they're told, oh, can you use zk in your application? They're like, oh, I don't really understand it. And so, how do we convey the utility of zk? How do we educate more developers and users the possibilities that zk bring into our crypto world and even non-crypto world? There's a lot of applications that are possible outside of crypto space. And then once we have education, we need products. We need applications that everyone can use and start realizing like just the benefits of zk technology. And hopefully we'll reach mass adoption in that journey. Any final takeaways from the panel?
Yeah, I don't know if there are many developers here in that, but if you are in blockchain and you are a developer and you don't know what's zero knowledge, I mean, I would fully recommend to take a look at that. I mean, probably I would recommend to go to Snark.js and do the tutorial there. In 1 hour, you will build a circuit, but you will understand the basic idea, because at the end it's not that difficult. It's just, again, it's just proving a computation, okay? And you understand this concept, you understand this idea, you see the applications there are, and I'm sure you will find out some applications that you can build using zero knowledge.
I only wanted to say that for me, or for us, zero knowledge is going to be even bigger than blockchains. From my point of view, I might be wrong, I don't know, but I feel that this is going to invade every product that we use. zk is the first use case. And actually, again, Risczero, I think it's one of the projects that, for me, it's really interesting. I don't work for them, but I have huge respect for the team because I think they have a different approach. You will find a lot of use cases where you can prove how hardware, or you can do things like outside of blockchains that are going to have real concrete use cases. I also wanted to add that this zk development that we got thanks to blockchains helped a lot FAG on FPC that are going to also be huge from my point of view. So cryptography on distributed systems are going to take the world.
I love it. zk is, huge in terms of its potential. There's a lot happening in this space. So if you're not paying attention, definitely learn more about the space. And, to your point, I think this technology has use cases not just in the blockchain space, but even outside the blockchain space. So with that, thank you so much, panelists. This was a really good panel.
Thank you.